Assalamu alaikum. Today my presentation topic is ant colony optimization problem, a probabilistic technique for finding optimal paths. My teammates are Joy Bhumi, Vedan Hussain, and I myself the presenter Sanjatul Hassan Siam. Before we dive into ant colony optimization problem, we have to first be familiar with the term swarm intelligence. Swarm intelligence is a collective system capable of accomplishing difficult tasks in dynamic and varied environments without any external guidance or control or no central coordination. Like sometimes we see a flock of birds flying together. Flocking helps keep birds safe from predators. A large group of birds has a much better chance of spotting predators than a single bird. In addition, staying in a flock means it is harder for a predator to identify a single target, and a group of birds can also confuse or overwhelm a predator through mobbing, thus achieving a collective performance which could not normally be achieved by an individual acting alone, as constituting a natural model particularly suited to distributed problem solving. Inspiration from swarm intelligence has led to some highly successful optimization algorithms. One of those algorithms is ant colony or optimization algorithm. So, about ant colony optimization. Ant colony optimization was first introduced by Marco Dorigo in the 90s in his PhD thesis. The algorithm is introduced based on foraging behavior of an ant for seeking a path between their colony and source food. Initially, it was used to solve the well-known traveling salesman problem. Later, it is used for solving different hard optimization problem. At first, let's take a look at the ants colony. Ants are social insects. They live in colonies. The behavior of the ant is controlled by the goal of searching for food. While searching, ants roam around their colonies. An ant repeatedly hops from one place to another to find the food. While moving, it deposits an organic compound called pheromone on the ground. Ants communicate with each other via pheromone trails. When an ant finds some amount of food, it carries as much as it can carry. On returning, it deposits pheromone on the path based on the quantity and quality of the food. Ant can smell pheromone, so other ants can smell that and follow that path. The higher the pheromone level has a higher probability of choosing that path, and the more ants follow the path, the amount of pheromone will also increase on that path. Let's see an example. Ants searching for foods. Let's consider there are two paths to reach the food from the colony. At first, there is no pheromone on the ground, so the probability of choosing these two paths is equal. That means 50%. Let's consider two different paths to reach the food as the probability of choosing this path is 50-50. The distance of these two paths are different, and following the shorter path will reach the food earlier than the other. After finding food, it carries some food with itself and returns to the colony. While tracking the returning path, it deposits pheromone on the ground. The ant following the shorter path will reach the colony earlier. When the third ant wants to go for searching food, it will follow the path having shorter distance based on the pheromone level on the ground. As a shorter path has more pheromones than the longer, the third ant will follow the path having more pheromones. By the time the ant following the longer path return to the colony, more ants already have followed the path with more pheromone levels. Then when another ant tries to reach the destination from the colony, it will find that each path has the same pheromone level, so it randomly chooses one. Let's consider it chooses above 1 in the picture located below. Repeating this process again and again, after some time the shorter path has more pheromone level than other and has a higher probability to follow the path, and all ants next time will follow the shorter paths. From this, let's construct our algorithm, the ant colony optimization algorithm. For this, we have to consider some things: ant density and ant quantity. Pheromone is updated in each movement of an ant from one location to another. Ant cycle. Pheromone is updated after all ants completed their tour. Let's see the pseudocode for applying the ant colony optimization algorithm. An artificial ant is made for finding the optimal solution. In the first step of solving the problem, each ant generates a solution. In the second step, paths found by different ants are compared. In the third step, path value or pheromone is updated. Thus, we have to repeat the steps again and again until the procedure stops or we reach the final destination. Let's see the mathematical terms of ant colony optimization problem. Pheromone update. The left side of the equation indicates the amount of pheromone on the given its x and y and the rate of the pheromone evaporation. And the last term of the right side indicates the amount of pheromone deposited, where L is the cost of an ant tour length and Q is a constant. Thank you.